So, what is an independent samples t-test? An independent samples t-test is used to determine whether two groups' means on the same continuous variable differs. This is a parametric test, so it assumes normality. Data must follow our typical bell-shaped curve. And if you're looking for help running an independent samples t-test, we have the U of G SPSS LibGuide, the Laird Statistics Guide, or the SPSS documentation for help. What are the assumptions of an independent samples t-test? There are 6 different assumptions that we must meet in order for the results of this test to be valid. The first is that the dependent variable must be continuous. Our second assumption is that the independent variable must be categorical with 2 independent groups. The third assumption is that the data must be independent. The fourth assumption is the dependent variable must approximate a normal distribution for each independent variable group. The fifth assumption is there should be no significant outliers. And the sixth assumption is we should have homogeneity of variances. And there's a star next to that one because we check that one once we actually run the test. Let's check our assumptions. Our first assumption is the dependent variable must be continuous. If, for example, we were using fake data 1 from our data set, we can look at this variable and say, does this look like a continuous variable? Here we see a bunch of decimals, we see a range of values. That's a pretty dead giveaway that this is a continuous variable, so we pass this assumption. Our second assumption is that our independent variable must be categorical. So, for example, if we were going to use the gender column, we can see that we have 2 different groups here. We have males and females. That means this assumption passes because the independent variable is categorical. Our next assumption is that we must have independence. This is normally determined before you actually run the study. So this is set up based on how you do your experiment or how you do your survey. It's pretty hard to check after the fact. But what we can do after the fact is we can look in each row and say, does this look like a unique participant? So if I look across row 1, this participant identifies as male. We have data for them for fake data 1, fake data 2, fake data 3, and so on. It looks like the data are independent because this is a unique participant. But again, we normally do this before we run the study. So we think that this assumption passes. Our next 2 assumptions we can check at the same time. So this is normality and outliers. To check normality and outliers, you can click Analyze, Descriptive Statistics, Explore. Normality, when we say the data must be normal, it means each group, in this case the male and the female participants, must look approximately normal. They must meet that bell-shaped curve. And for outliers for each group, males and females, we want to make sure there's no data that falls outside of our typical range of values for each of those 2 groups. So again, to check for normality and outliers, you click Analyze, Descriptive Statistics, Explore. What we do here is we take our continuous dependent variable with a little yellow ruler to indicate the data are continuous, and we take that from the left side and put it in the box that says dependent list. We take our categorical independent variable, which either has 3 colored circles or 3 little colored bars, and we put that where it says factor list. If your data do not have the correct symbols, you might have to go to variable view and measure and check in the measure column to see that these are labeled correctly. To get the yellow ruler, it must be scale data or continuous. To get categorical data, it must be either ordinal or nominal to get those circles and those bars. There's another thing we have to check here. We have to click where it says plots. Under plots, for descriptives, you will uncheck sum and leaf and check histogram. You will also check where it says normality plots with tests to get the actual statistics. Then you can click continue and you can click OK, and this will generate both your normality check and your outlier check. If we do that, we'll get several pieces of information in our output window. We can scroll to where it says tests of normality. This gives us a statistic to check whether we have met our assumption of normality for each of our 2 groups, our male group and our female group. This gives you 2 different options for normality. The one kind of in the middle of the table is called the Kolmogorov-Smirnov statistic. We generally use this if we have about 50 or more observations per group, and you can see whether your data are statistically significant by looking in the column that says SIG. Because our groups are less than 50 per group, we're actually going to look on the right-hand side where it says Shapiro-Wilk statistic, and we can look in the column that says sig to see whether this is statistically significant. Here, if p is less than 0.05 for either group, it means you have failed normality and you cannot use the independent samples t-test. Here, both of our p-values are greater than 0.05, which means we're okay. We have passed normality for both of our groups. We are allowed to continue with the test. That's how to check normality with a statistic. Some folks also prefer to do what's called visual inspection. So if we have selected the appropriate things in the plots window, we will also get some graphs generated for us. So for example, we have asked for histograms. We can use our histograms for visual inspection. And what we're looking for here is the data for each of these graphs should approximate our normal bell-shaped curve. So data highest in the middle and lowest at the ends. If you squint at these a little bit, they look pretty close. It's not exact, but with our p-values showing greater than 0.05 and our graphs looking approximately like a normal distribution, we could say that that passes. There's another graph we can use for visual inspection. That's our QQ plot. It's a little bit lower down in your output file. And what we're looking for here, it's a plot with a line going across it. We're looking for our data points to be fairly close to the line or touching the line. If you squint a little bit, these ones look okay. There's some data points on both that don't quite touch the line. They're pulling away a little bit. But in general, most of the data points are pretty close to the line. So you could say with the p-value and your graphs that this passes normality. In the same output window, we will also get information about outliers. There are multiple ways to check for outliers, and this might be dependent on your field or your lab. The way SPSS checks for outliers is what's called the box plot method. So we can do visual inspection of our box plot to see whether we have any outliers. The bar in the middle is your median. We have our interquartile range in color. Yours is probably blue, mine is red because I changed it for the presentation. And we have our whiskers. And what this data shows is the bulk of the data should be within those whiskers. If you have any data points outside of those whiskers, here in the female group, we can see a red dot with the number 16. In the male group, we can see a red dot with the number 12. That means that row of your output is actually an outlier. If these were stars, they would indicate extreme outliers for those conditions. So it looks like we've got one outlier in the male group and one outlier in the female group here. So we would probably need to remove those observations before we can run an independent samples t-test. Outliers can skew the results of your data, so you want to make sure you're dealing with them appropriately. All right. If you have passed all assumptions, then you can proceed to conducting the independent samples t-test. This is a warning to always check your assumptions. For example, we've identified that there are potentially 2 outliers here, and those outliers might need to be removed before we actually conduct the test. Just for practice today, I'm going to leave the outliers in. Some folks leave outliers in as long as they're not considered extreme by whatever standard they're using. But you want to be cognizant of the fact that outliers might skew the results of your analysis, so you want to check for those. So we've passed our assumptions, except potentially those outliers, and we want to run the test. How do we actually run an independent samples t-test? You click Analyze, Compare Means and Proportions, Independent Samples t-test. This is one of the tests where SPSS lists the actual name of the test, so it's pretty easy to find it as long as you're looking in the right section. So to run the independent samples t-test, click Analyze, Compare Means and Proportions, Independent Samples t-test. That will open up the independent samples t-test dialog box. What you do from here is you take your continuous dependent variable with your little yellow ruler, and you drop it in the box that says test variables. Then you have to take your grouping variable. In this case, this is your independent variable. It should have either colored circles or colored bars to indicate that it is categorical. And you put it where it says grouping variable. You're not quite done yet. There is one extra step that sometimes trips people up. You have to click where it says define groups. SPSS is not very smart. It doesn't necessarily know which groups you're trying to compare. So when you click Define Groups, it will open another small dialog box that's called Define Groups. And you have to tell it which numbers you're comparing. So what is Group 1? What is Group 2? Here our Group 1 is a 0 and our Group 2 is a 1. You might have other numbers. So you might have, if you have a variable with 4 different categories, for example, you might want to compare group 1 as the number 2 and group 2 as the number 3. So this might depend on your data set. You can always go back to your data to check what your numbers are. And if you have words in your data set, make sure to click the button that has like an A and a 1. It looks like a crossroads, and that will switch you back and forth between text and numbers so you can check what numbers are each of your group. So once you've defined your groups, you can click Continue. And then what we're going to do is click OK. This will give you your output for your independent samples t-test in the output window. And there's quite a bit of stuff going on here. So it starts by giving you a group statistics table. This just gives you some information about your data. So for example, it breaks down male and female. It gives you the N or number of observations for each of those groups. It gives you the mean, the standard deviation, and the standard error of the mean. One of the assumptions I said you must check when you actually run the test. We can see that in the independent samples t-test output. It's on the left-hand side where it says Levine's test for equality of variances. This is our homogeneity statistic. Here we look where it says SIG. There's an F beside it, and then SIG. SIG is going to tell you whether or not you have passed homogeneity. As this is an assumption, if P is less than 0.05, you have failed this assumption and you do not pass homogeneity. Here we can see our p-value is actually greater than 0.05, so we have passed homogeneity. We're good to go. If you have passed homogeneity, you are allowed to continue to interpret your t-test using the top line of the independent sample test box. If you have failed homogeneity, if this SIG value is less than 0.05, you read the second line of the independent sample test box. As we have passed homogeneity, we're going to read from the top line. Sometimes these are the same, sometimes these are different. But we're going to read from the top line where it says two-sided P. Your t-test gives you a t-value, your degrees of freedom, a one-sided p-value, and a two-sided p-value. If you had a hypothesis from previous research, for example, that you might expect, for example, a difference in a certain direction, you might read the one-sided p-value. But if you don't have a hypothesis or any reason to do a one-sided t-test, it's more common to do a two-sided t-test. And if you don't know which one you should be running, probably look at the two-sided p-value. So the two-sided p-value is going to tell you within that continuous dependent variable. Looking at our two groups in our independent variable, here males versus females, we're looking to see, does the continuous value differ between our male group and our female group? If P is less than 0.05, it means we have found a statistically significant difference between our groups, and we can say, yes, our groups are different. Our p-value here is 0.159. This is greater than 0.05. If we get a p-value greater than 0.05 here, all we can say is we failed to find a difference between the groups. You can actually look at this a little bit as well. Up in your group statistics in the mean, we've got 87.4 versus 86.8 if you round that. We fail to be able to say whether those two means are different from each other. And then the last piece here, it gives you the independent samples effect size table. The effect size just tells you the size of your effect. Is it a small, medium, or large effect size? How different are the groups potentially? The effect size that you use for an independent samples t-test is Cohen's d. So we'll look at point estimate. We can see 0.529. That's our Cohen's d for our effect size. And that's how you run an independent samples t-test.